Okay,
Sure.
so the question, it would be a two-part question. Okay,
Mm-hmm.
and what you'll need to do is you'll need to find the kth largest element in BST. So in this
Okay.
example, if we see the input here is for as an input k is 3, and we
Mm-hmm.
have a BST, and if we see the third largest element, that's
Mm-hmm.
15. So we return 50.
Okay.
So how would you approach it?
Okay. 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 So it's a BST.
Mhm.
So yeah, what I'll do is like I'll do one thing which I can. It's which clearly comes to my mind after seeing this question is like I'll
Mhm.
create one map.
Okay.
In map, I'll give the what you can say the count for each uh, tree node, and then
Mm-hmm.
I'll keep the value of tree node in the next parameter. And what I'll do, I will traverse the uh, linked list with in order traversal. As we know, in order traversal of BST will give you the increasing uh, sorted order
Mm-hmm.
of, of the BST.
Right, right.
Yeah, so whatever the case element, we can directly get it from map.
Uh-huh. Cool. So if you do, and so what we are asking here is that we would be doing we would be finding the largest element, right? Kth largest element.
Right, right.
So do you think in order would be a optimized way of doing, not, I mean, not completely optimized, but should we do an in order because it will start from the smallest element, right?
Yeah, so again, we need to, I guess, we can, what you can say, reverse the map order, and then we'll get the bigger element at the first, and then we can find out the kth largest.
Okay,
So,
that's fine.
so
Let's do this. Let's start implementing.
okay, so shall we first consider how much time it will take?
Yeah, we'll consider. I'll ask that question.
Okay, and otherwise we can find some better solution if it is not within the acceptable limits.
That's fine. I will say it. Just first implement the solution.
Okay, sure, sure, no issue. So we have here one class.
Hmm.
Uh, so I believe the Trino definition should be like this. Uh, data.
Okay.
Can we modify the tree node? Like we can.
No, we cannot.
Okay,
We should not, ideally,
okay,
right? I mean, we never modify our inputs, right?
right. I mean, we can take some extra variable, with this, which could be help us in. But yeah, as you said, we should not modify the tree structure. So,
Mhm.
so this should be our tree structure. Then we can have one solution class which will provide solution to this question. So this will return a map. Okay. So So we are writing one method in order traversal,
Mm-hmm.
which will return us a map. Here we are giving the root node, I believe. So this, yeah, root node we
So,
can
so
give
our
BST.
base method, so our actual method would just return an integer.
Yeah, yeah, yeah.
Our actual
It, yes, yes,
method should only return an integer.
yes, yes.
It would
So
take,
this is the helper method.
okay, it would take tree node as an input and return an integer as an output.
Yes, yes. So we'll be writing it. So public uh, int get get node get largest node. Then it is accepting one uh, root node. So I would like to first work on this helper method. Then we can work on this one. So I'll keep it private. So here we'll take one temporary map.
Okay.
You, you can say this map. Now, if root equal to null, then we just return temp, which is having null.
Mm-hmm.
So initially temp would be initialized with null. Then what we can do next is like um, in order travel. So in order traversal of root dot left,
Mm-hmm.
and we'll perform some map operations here. Then we'll do in order traversal of root dot right. So now
Okay.
here uh, we can do one thing. We can declare this as a global variable in our solutions class,
Mm-hmm.
and we can also declare one root here.
Okay.
So this dot root we so just we can keep one copy of root with this. Might be we will use it in future
Mm-hmm.
if required.
Mm-hmm.
So can can do it like map dot um, put put root dot data and here root.
Okay.
Okay. So better I should use here tree map so that we can get the sorted order in the map itself.
Mm-hmm.
So so we are keeping the data inside the map with the root, and then yeah, so we can return this map.
Okay.
So again we can define the same result is equal to So here we must be getting integer k, right?
Right,
Infinite
right,
k.
right.
Now, so once we have this, use collection dot reverse. I don't remember the exact syntax, but we have an reverse method in collection class.
Mm-hmm, mm-hmm.
Uh, so
Does collection dot reverse work on map?
I really don't sure about it, but if it's not there, then we can develop a method for reverse. Like,
Why do we need that?
because here here the order which we get in map in the result map would be in the naturally sorted array. It would be in the naturally sorted order, like the incremental order. So, but to get largest kth element, we
Mm-hmm.
should have the decremental order.
Do we really care about that? Which order it is?
Uh, okay. Then to find kth,
Would
okay.
also would okay, so you are using a tree. You change it for tree. Okay, fine.
Yeah. Uh, so,
So since you are using tree map,
mhm.
so do you think you can do something to the tree map rather than using collection dot reverse?
Okay. Uh, so, to store the largest element first.
Not exactly that, but what I'm trying to say is that while defining a variable, can you do
Mhm.
something to the tree map constructor? Can you use
Okay.
any different tree map constructor which
Okay.
can
Okay. Okay. Got
which
it.
can make you, I mean, what you were trying to do with collections dot reverse, right?
Right. Right. Yes. Yes. So here, uh, I'm not sure because I never used that. But as you're saying, we must be having some comparator method here, which will give us the the sorted order in decremental way.
Mm-hmm.
Um, maybe we can use that also. But I sorry, I'm not really sure how to use that comparator method.
Okay. No
Uh,
problem, not a problem. Just go ahead with what the approach it should.
okay. Okay.
Mm-hmm.
So we can see. Uh, uh, Key set. We need to create a key set, and with that key set, we can retrieve the values
Mm-hmm.
from that key, and then we can sort that key order.
Mm-hmm. Mm-hmm.
Sorry, the uh, element order with that key.
Mm-hmm.
So we can do one thing for integer key map dot key set. Uh, so int map dot get key. Uh, as you're saying, okay. So here, as I'm not aware about the comparator method, which can reverse the map itself in sorted order in decremental way, I like to use here.
Do
Uh,
we do we really need a comparator, or do we really need to reverse it?
okay. Hmm. So how can we then get the kth value? Since suppose if we have nodes like 10, 8, 7, 4,
Mhm.
2. If you want second kth, that is the eighth element. You can get this only if we have
So
the
rather than reversing the map, the
okay,
order of the map, perhaps you can do something with k,
right, right.
and
Yeah,
you might not need to reverse. You would not need to reverse the map.
yeah. Means if we know the total tree length, then we can negate it with the k, so that the result we can get the result, and that can be used.
Do we know that?
So yeah, we can get that value from this in order travel itself.
Mm-hmm.
So we can keep on static variable count. Uh, so uh, public static count variable in case to zero. And here,
Mm-hmm.
sorry,
So do we need to create the? Do we need to have this count while traversing the uh, while doing an in-order traversal? Don't I mean? Is there anything else by which you can find it? Do we have anything else in here?
mm, so uh, we can do one thing. Uh, we can also see how many tree node objects are created,
Where?
and we can count that. So we can here itself we can do one thing. We can increment the count so that we'll
Okay.
come to know how many tree nodes are created.
Where exactly?
So whenever we are creating a tree node,
Mm-hmm.
it will create an object for this, right? So in the while creating the object itself, we can count the number of objects created by this tree node. Like suppose if now I'm doing the insert, right? If
Got
I'm
it. Where would we track this count?
so we have okay, so I should use this in this tree node itself. Uh, otherwise, yeah. So yeah, we can track it here also. Since it's a public variable, it can be used by this tree node class, which is in the same package. So yeah, we can use this.
So since it is in the same package, we can. Uh, okay, so you're referring this count. Okay, static variable count
Yeah,
inside. tree- Okay.
yeah. So
Mm-hmm.
the number of tree node objects are created. If we increment the count variable, then we'll get the how many we'll get the count of the number of nodes created
Okay.
while insertion.
Mm-hmm.
So now we have the count.
Okay.
Then uh, we just have to use it here. So now we have the count. So what we can do here is like um, int res is equal to, you can say, count minus k.
Mm-hmm.
So total 10 nodes are there. We want third largest.
Mm-hmm.
So here we can just check Uh, so sorry, my bad. Actually, here I did one mistake.
Okay.
I should not put here root.data. Instead of that, I should put here. Um, I'm taking one more static variable.
Mm-hmm.
Um, static data count and data count plus one. So now I have the value if value sorry if value equal to data count, sorry,
Mm-hmm.
if value is equal to res,
Okay.
we can just return the root dot data. This
Okay.
is not required. I'm removing it.
Mm-hmm.
So yeah, this tree node is not required. Means if we are writing an insert method into tree node, then we would need it. So yeah,
So
shall I go through the flow one more time with sample data?
yeah, I would say do a dry run
Okay,
and just review your code once and see if there are any problems with this code.
sure. Yeah. So here we got the tree node. So here we are declaring on one map. This is temp. Okay. Now here we have a root node. Suppose k is equal to 2
Mhm.
and root node we have is like
We
10,
we can use the same yeah, we can use the same example here.
right? So root node is 10. So now is already not a traversal route. Okay. Um, I created this. Okay, sorry. Yeah. So map dot result. So int res is equal to count minus k.
Mm-hmm.
So this count variable, as we discussed, it will give us the number of tree node added minus k. Suppose we have here
Mm-hmm.
1, 2, 3, 4, 5, 6, 6 tree nodes are there. So 6 minus 2 will be 4.
Mm-hmm.
Now, uh, okay. So in order traversal will go with this method.
Mm-hmm.
So here we have root node as 10.
Mm-hmm.
We'll check if 10 equal to null. No, it's not. So it will not return 10.
Mm-hmm.
So it will do the left
Mm-hmm.
of 10, which is 4.
Okay.
So again it will goes here. So now we have 4.
Mm-hmm.
So it will do here root dot left is, since left is not null,
Mm-hmm.
we'll get here 2.
Mm-hmm.
And now here 2 will come.
Mm-hmm.
So now the root is null since we traverse left. So it will return the control
Mm-hmm.
here itself. Uh, so, so 10, uh, 10, then it went to 4, then it went to 2.
Mm-hmm.
So it returned to here itself.
Okay.
Uh, so it will return the control here itself.
Mm-hmm.
So here we got the temp.
Mm-hmm.
sorry, the null, then it will goes here, and it will put 2 in the map. So
Mm-hmm.
we'll keep one map here. Map would be having 2. Now it will see if root dot right is not equal to null. Suppose here um, 4 is null currently, or is it not? Yeah, 4 is null. So it will again goes to, it will again goes here 4. Uh, 4 dot left is null, so null will be here. Root is equal to null,
Mm-hmm.
so it will return the control. Yeah, so it will not print anything. It will return to this fourth node. Since in the recursion it will create a stack internally, and it will push the recursive calls in that stack.
Mm-hmm.
So now it would be having 4, so it would just put this into the map,
Okay.
and it would see if 4 has its right child. It's not there, it will return the control to 10.
Mm-hmm.
So 10 would be here. Now it will check uh, if it will just put 10 into the map.
Yes, Pankaj.
Yeah, Gustav. So
Just a quick time check. We took 30 seconds more here, so I'll give you 30 seconds or 1 minute more. We are
right.
past 30 minutes. We have 15 more minutes. Okay.
Okay, okay, sure. So here we came up to 10. So it kept that 10 into the map.
Mm-hmm.
Okay.
Mm-hmm.
So here it would be having first 1, then the tree node 2. It will be 2, then tree node 4, then 3, then tree node 10. Okay,
Mm-hmm.
so this is the no, map data. So
Okay.
now it will go here. Sorry, it will go here, and since we are done with this, it will go to the right. So 10 has right, which is 20. So 20 would come here. 20 would come here, and it will again check the left of 20, which
Mm-hmm.
is 15.
Mm-hmm.
So here 15 is there. So it will again take left of 15, which is null. So it will return the control
Mm-hmm.
to 15 itself. And now it will get to the next line and will put that into the map. So map would be having now 4 and 15. Okay, so now it would go to right of 15, which is null.
Okay, I got it.
Yeah.
Let's
So
say let's come back. Let's come out of the in order
okay,
traversal, right? And
okay,
let's yeah.
okay. So here we got the map similar like this. Here we'll keep it here.
So
Yeah.
at what point is our count increasing?
Okay. So sorry. I forgot to increase that count here.
Mm-hmm.
I should keep it here.
Okay.
Yeah. So yeah. So we got the map structure here, which would have the this sorted data like 2, 4, 10,
Mm-hmm. Mm-hmm.
2, 4, 10, and 15, 15, 20, 40. So
Mm-hmm.
now it will we have integer res as 4. So now we'll take the key from this key set.
Mm-hmm.
uh, as we discussed, it is starting from 1. This is 1 2 3 4 up to 6. So here I did one more mistake. So tree node value I should take here at map dot get key. So value dot data. So sorry, my bad actually. So this is key. So I need to check here if key is equal to res, and it should uh, return that value. So map dot get key.
Mm-hmm.
Yeah, and return to delta. Yep. And else it will return suppose -1, and check that in the calling method. If it's -1, then we can say we didn't found the
Mm-hmm. Mm-hmm.
intended root node. Yep.
There can be an
So
element negative one, right?
sorry. Oh yeah, right, right. Yeah. So yeah.
So
So yeah.
we have 10 minutes, okay? So I would want to know that how would you approach it without using so point is what is our time and space complexity? Let's first discuss that.
Okay. Okay.
And can you write it down as well? Some
Yeah. So uh, time complexity we can calculate here. So here it would take order of n for this for loop, and this in order traversal method will take n log n. So n log n plus n, which is equal to order of n log n time to take.
what would be the space complexity of this?
Would be order of n, since we are taking one extra map for this.
Okay. Can you write the reason besides it because of extra?
Sorry.
Can you write the reason for that extra space as well?
Yeah, as we used extra map
Yeah, just
here.
write it
Yeah.
besides your answer.
Okay.
Okay, cool. So now, can you do it without using any extra space?
Okay.
And
Yep. Please go ahead.
yeah, that's it. That's it. Just how would
Okay.
you do it without any extra space?
Okay. So we can use here a heap structure also instead of map, so that we can get the max heap, but still it will have the space complexity. So we can, so if you do in order traversal, later. Okay. I think we can just increment here data count. We can check here itself. I think we can check here itself. Uh, as we wrote it earlier,
Mhm.
we can
I
We can
just
pass here two parameters more like int res and int k. We can just check. Okay, sorry. So here we can just take if data count equal to res,
mhm.
then return. Data. So this would not be required. Map. Let me try run it once. I'm really not sure whether it will work or not. Yeah, so here we got the root, we got the res, and we got the k. So it will be equal to null. So suppose you want second highest, which is we have 15 and 15 and 40. So second highest would be like 20. So here would be equal to 10. And so it would give us would print the thing. This would definitely print the thing in the sorted order up to here. Yeah, it would give us the correct result. Account. Okay, so yeah, right. Yeah.
Okay. Just do a quick code review of the code which you have written
Okay.
and
So
see
shall
if
I remove the map code that will have the
it's fine. Just
punch?
keep it there.
Okay.
Keep it commented.
So return the result. Okay. So we'll start from here. So we got two static variables count and data count as 0. Then we have root equal to 10 and k is equal to 2. So here we pass the root. There res would be, as we discussed, it would give us 4 value, that is so like 1, 2, 3, 4.
Yeah, just do a code review. That's it.
Okay, okay,
If you see that there is something which you can improve or
okay,
which you
sure,
need to
sure.
change, and then
Okay,
we'll call it a day. Yeah.
yeah, sure. So result count minus k. Yeah, I think we are good.
You're good? Okay.
Yeah.
Fine. Then let's stop here. Do you have any questions?
No, not currently.
Okay, so our time is up anyway. We will stop our interview and I'll give you the feedback.
Yeah, yeah.
So, first of all, about class design, I think there could, if you, one small improvement around class design.
Okay.
First thing is you cannot use count from solution inside Trino. You can, but you should not,
Okay.
right?
Right.
The reason being solution is not implemented. So by the time tree node is written, solution would not be implemented,
Okay. Okay.
right?
Okay. Right.
So that would not make any sense.
Yeah, yeah. Sorry, also I asked you before that shall we change the keynote structure? You said no, so at that time only I should not take this count here.
Yeah, I mean, I should not require to tell you that,
Right. Yeah.
right?
Yeah.
Point is, it's your solution, and the way you want to do it, you can do it. Point is,
Yeah.
this class design in itself is not correct, right?
Okay.
Then let's come to the next part. A small thing, solution should have been Pascal case. The class name should have been in Pascal case.
Yeah. Okay. Okay.
Yeah, it's just a small nitgrit. The second
Yeah.
next thing is again data count. I would expect it to be in camel case, and it could have been private,
Okay. Okay.
right? So other than that, I guess mostly the core the syntax was mostly fine.
Okay.
Let's come to the logic,
Yeah.
right? So the thing here is that first of all, we never required to use map. We were never required to use map at all, right?
Right. Right. Yes.
You could have rather you even if you had to use a data structure, you could have used an array or a list, probably a
Okay.
list, right? Or say a queue or a stack.
Okay.
If you're doing an in-order traversal, you could have used a stack and got there is some discussion, there's some disturbance in the background.
Yeah. Just a minute. Yeah. Yeah. Costa, please go ahead now.
Yeah. So you could have used a stack, and since it was the kth largest element, you could have removed the fourth element from the stack. Or you could have simply used a list and you got the last element. Now the next thing is if you are using tree map,
Okay.
I would have expected you to know the constructors of tree map. So when you said that you want to reverse it, you could have reversed it using a different constructor. Inside that constructor, they use a comparator. If you would have said that you do not know the syntax of comparator or how to use it as an anonymous function or in a different as an anonymous class, it would have been fine, right? You could have just written comparator.
Okay.
But then for that, you should have known that tree map has a comparator inside
Right.
its constructor.
Yeah.
Second, next thing is you were never required to use to reverse the map.
Okay.
I had to push you. a little bit to make you realize that map had to be reversed. So even with your solution, the map could never be reversed. There was no requirement for the map to reverse. We could have simply got the answer just by
Right.
checking the element from the last, right? Length
Yeah.
minus 1. Again, you did not need count here. Although this count here would not work, but still, you never required count here because the number of, for getting the number of nodes, you could have simply used map.size, your result.size,
Yeah. Yeah.
right? That would have been total count of nodes. Now the next thing is in-order traversal is not uh, the right way of doing it. Would not have been uh, uh, very what do you call it? Uh, an optimized solution. Not very. It would not have been an optimized solution. What you could have done rather is you could have traversed to the right node and then done an in order in a reversed way. Right? It would have been an in order, but it would have been in a reversed way. So you would have got to the answer much quicker.
Okay.
Okay. Next thing is uh, for your initial solution. Just I'm talking about just the initial solution here. This for loop,
Hmm.
sorry, this if condition would have never worked. The reason is if the first condition doesn't match, it would simply return -1 and exit.
Right. Right. Sorry. Yeah. I should have kept that in the end. Yeah.
Right.
Yeah.
So again, this was another problem uh, with your initial solution.
Right. Yeah.
The next problem was data count inside map.put.
Hmm.
Okay, so inside map.put you are using data count. So data count, the value of data count is never incremented. So it would always be one. So you would anyway have just one element inside your map,
Right.
right? There wouldn't be any more elements inside your map at any point of time.
But data count I'm incrementing in the next line.
That you did later, right?
Yes. Yeah. Yeah. Yeah.
So these were the problems with your first solution.
Okay.
Okay. Now consider this. For your next solution, let's talk about your in-order traversal. Right. So what you're doing here is you're iterating through. So you're iterating through your in-order route, but point here is you are never incrementing your res or k. You are never setting your res or k inside in-order traversal. So honestly, I do not know what would that res or k would be. Plus, when you're right, so
So
these were
these
the these were the
these
big. Sorry,
yep,
yes.
yep, please, please. Yeah, so these were coming from the calling method, right? So there we calculated the RES, that is
Yeah, but
from,
for recursion, you are saying root dot left and root dot right, but there is no
yeah, yeah.
RS.
Sorry, yeah, yep, yeah. I can, yeah. I should
So
have.
yeah, it's fine, it's fine. No need to update it now. So uh, this part, right? I
Mm.
mean, we do not know how is the rest changing, how is K changing. We have no idea about it. Right? Since there was not much time, I could not tell you that. I could have given you a hint if we had more time and see how it goes further, but we did not have much time, right?
Right.
Now, coming to your time and space complexity, it was not to the point. So, yes, for the first implementation, what you did, this would have taken n amount of time if we have n nodes in our tree. However, in-order traversal doesn't take n log n. Even in
Okay,
in-order traversal, every node is visited only once. So, yes, it is n, just
okay,
n. It's not n log n. Space complexity is correct, but the reason is wrong. So the reason which you gave me is that the space complexity n is n because we are using a map. That's not correct. I mean, that's correct, but not complete answer. When you're doing an in-order traversal,
Mm.
you're adding you are adding stacks to it because you're
Yeah.
doing a recursion.
Right. Right.
So when you're doing recursion, it adds to the memory because of the
Right.
stacks, right? So
Yeah.
for this recursion, you would be using n space, order of n space. So it would be
Okay.
order of n plus order of n, which is order of n. Sorry,
Mm.
order of n plus n, which is n,
Right.
right? So the
Yes.
space complexity was incorrect as well for the second case,
Okay.
right? So what my recommendation to you here would be that uh, practice around trees more,
Mhm.
right? Make sure that your class design just give some thought to the class. I mean, I know you can do a good class design, right? There's no doubt that you can. So you used count here and here just because so that you can solve the problem, right? Do not
Mm.
do that.
Right. Okay.
Always follow good coding principles while you are, even if you are on an interview solving it for data structures. You
Right. Right.
cannot you cannot move away from proper coding standards,
Right. Right.
right?
Right.
Avoid using class variables if possible.
Okay.
So this solution mostly could have been done without so many class variables, maybe one to
Mm.
track the count, right? Or that's, I mean, even that could have been done inside the recursive method itself. Now,
Okay.
uh, and practice a bit around understanding space and time complexity about around different algorithms.
Okay.
Spend some time. So whenever you read any algorithm or whenever you read any data structure, just make sure you spend 2 minutes to understand their space and time complexity and why is it so what it is.
Yeah. Yeah.
So just about the second question which I asked you, using constant space. So even without map, it wasn't constant space, right?
Yeah.
Because of
Yeah.
the stacks.
Recursion is there. Yeah.
Stuff. So that's it from my side.
Yeah. Yeah.
Do you have any? Is there anything you want to ask me, or uh, is there any feedback you want to give it to me? I'm all ears.
Okay.
Anything you want to ask me, or anything, any feedback you want to give me?
No, your observations were totally correct. I need to improve in some areas.
Yes.
Yeah, we'll take note of those and we'll work on those. Yeah, whenever I use this docs, this Google Doc, instead of Eclipse editor or pen and pencil, I'm facing difficulties while doing the dry run. So,
So,
that is,
if you give any interview right now,
yeah,
you, I mean, in any interview, right? Unless it is a machine coding round,
yeah,
you would never get an ID,
right, yes,
right? So if it would have been a face-to-face interview, it could have been on a pen and paper.
right, right.
It is not.
Yes, yeah. Yeah, but the other
For
interviewer don't look for exactly the correct syntax and everything. They just yeah, means here if I miss
if you go for any big tech companies, right?
yeah,
They would certainly check your syntax.
okay, okay.
I mean, uh, say Amazon
Hmm.
or I mean Facebook or any other company, Microsoft.
Yeah.
right? Or even say the unicorns which we have, like Zomato, Poyo, Cardiff,
Yeah.
whatever they are, they would check your syntax
Right.
always, right? So I mean, I have had experience around it. My friends have given interviews in those companies. They know.
Mhm.
Even for Daily Hunt, I mean, there are many companies, and they all check syntax.
Right.
There shouldn't be any runtime errors.
Right. Yes.
So that's there. I mean, practice. I would say uh, practice on the section which is provided by the platforms. You're doing
Yeah.
it on GFG or Lead Code or wherever you're doing it, Hacker or Rank or wherever.
Yes.
Make
Yes.
sure you practice DSA without intelligence,
Right. Yeah. Yeah.
right? And you can do a dry run,
Yes. Yeah.
okay?
Yeah.
And make sure that you can do a dry run in a recursive order,
Yeah.
in a recursive code as well.
Right. Yes. Yeah. So recursive code driven, I'm struggling today. I didn't practice that before.
Hmm.
I thought I knew how to do the dry run for recursion.
Hmm.
I think I did fine today, but I should have done it better. So,
Yes. So, I mean, say you are getting 30 minutes, right? So,
yeah.
even for sweat profiles, they do ask trees,
Yeah. Yeah.
right? So, it's not, I mean, do not expect them to just stick to strings or arrays. There can be a whole lot of problems with strings and arrays, and they can be mind-boggling. But
Mhm.
uh, do not, I don't think you would get much difficult algorithms or very difficult data structures. But
Mhm.
yeah, the tree part and in order, post order, pre order, traversal part, or finding smallest or largest element, they are pretty trivial questions, I would say,
Mhm.
right?
Okay.
And they can be asked. I'm not saying I mean, most probably they wouldn't be because these questions are already out, but for maybe for sweat profile, they can be. I'm not sure.
Right.
So usually they avoid asking questions which are already present outside.
Mhm.
The probability of asking such questions is uh, comparatively lower,
Right.
right? For sweat interviews or for SUI or AE interviews, but still,
Right. Yes.
hmm, any.
And one more thing. How was my approach uh, for means
So
for
your
conveying to the interviewer the thought process of mine?
your approach. So you were talking to. You had a good communication.
Okay.
That's good. Moreover, what I would say is that the approach was okay,
Okay.
right? I was expecting you to complete it sooner,
Okay.
right? But that's fine. I think that's okay. But then again, your approach to a certain extent was correct, right?
Right. Okay.
The Actually the red flag was count, to be very honest.
Yep. Yeah.
So it was a big red flag to me. First of all,
Right.
even if you're using a static variable,
Mm-hmm.
uh, I mean, if you notice, there are no data types. Plus, you cannot just use count plus plus, right? I mean, let's say even if you are using a static import,
Mm.
then I mean, you could have mentioned it. Usually, the way we use static variables is class name dot variable name, class name dot function, which makes it much easier to understand,
Right. Right. So yeah, I should have used class
right?
name before the count. Yeah.
I mean,
But,
first
but
of all, you shouldn't have used it at the first
right.
place.
Correct.
But
Correct.
then,
Yeah.
even if you would have used it, I would have expected a correct approach, right? The data types should have been here.
Right.
So,
So
the
uh, one, one, one more thing,
Mm,
Kaustav. While using means similar variables like count, I do need to
mm,
ask interviewer, right, that shall I use this variable here, or it's pretty much obvious that I should not do anything. Is
uh, do anything where?
yeah, I mean, just like today, I should have to ask you whether I use count in the tree node structure itself, or shall I find some alternative way?
So the answer of the interviewer here would be: do you think you should add count here? Why do you need to add count here? What is the reason?
Okay,
So the tree node would anyway be constructed way before you write the solution.
right, right, yeah. So,
So you need to have that in consideration.
okay,
Because this is something which is very obvious, right? And it poses a red flag, even if you ask this question. So asking questions is good, right? And
hmm,
obviously uh, there are no stupid questions, for sure. But
hmm,
then the question you ask tells a bit about what the way you are thinking,
right, right. No,
right?
because I,
And the
yeah,
approach you are taking. And the approach you are taking is not exactly correct. So what I get from your approach is that you're saying that we would be defining tree node and we would be defining this class at the same time, right?
yeah,
Which is not the
yeah,
case, which is never the
right.
case. Data structures are defined way before the solution, and data structures need to be independent of the solutions and any solutions which we are writing.
Yes, yes, yeah,
The basic concept of which is encapsulation.
right, right.
So the encapsulation was breached here to some extent.
Yes, yeah, yeah.
So the approach you took from a bird's eye level was correct, right?
Yeah.
Just from the bird's eye level, it was correct. It wasn't it. When we
Yes,
come to when we go into bit detail of it, it shatters.
right. Yes. Hmm. Got it.
Anything
Yeah.
else?
And now, Kaustav, I'm pretty much good at this point.
Thanks. Dude.
Yeah, thanks a lot to you. So you're taking too much efforts for people like me, to prepare for the interview. So it's really an appreciating thing.
Not a problem.
I hope
It's my
most of
pleasure.
the people got benefited with your help and support.
Thank you. Thank you.
Yeah. Thanks, Kaustav.